Hello, welcome back to Sushi Live Noding. In this episode, we're gonna take a look at this new marching cubes nodes. It's been around for a while. It's kind of hidden. You need to have SK image or PyM cubes library in order for this to work. So it's using marching cubes algorithm to find ISO surfaces given the scalar field. Okay, it's not easy to understand, but you just look at the example and you might actually create something. So this is one example using n-gon with four points, and then with a vector field that creates boundary, and with marching cubes you're gonna get something like this. So I created the setup here. Okay, first of all, before I play around here, I'm gonna show you in the preference under add-on SVerchok. There's this extra nodes, and if you enable this, like if you upgrade the pip and then install the SciPy, upgrade it, etc., it's gonna give you the ability to use the nodes. So this is the node, marching cubes, and I'm using scikit image. There's a pure Python but slower, scikit image faster. And let's just play around with the parameter with this setup. So you can see you can really create really unusual design very quickly. Okay, so that's one. Okay, there's another one like this. And this is only using just a basic setup. So there's this attractor field which actually comes from this one of these nodes. It's very unusual, this curves, surface, and fields. Very, I think, similar to grasshopper. It contains some kind of way you can plug in algorithm. In this case, I'm using the inverse fall off, and you can, with join mode as average, you can change this. So there's actually a circle, right? So there's a circle somewhere there. It's almost like the donuts. And I'm using this vector p field. If I use prop viewer draw, plug this in. So I have those grid of points, and I'm using circles just to scatter circles around that area, and it's creating a scalar field. That's when you pass it on into marching cube. It's kind of like a volume that's become a surface, more or less. That's the idea. This can be just a point. Let's see how it looks like as a point. With points we don't have radius, we have only amplitude, but we can increase the number of points. Okay, this actually needs to be separated, I believe. It should be a little bit more like that. Much easier to understand. There we go. So we can have this bounding box that we can resize if we want to. And yeah, occasionally we have that kind of glitch. Anyhow, we have a bounding box. We have control over the amplitude. So it's things like they're almost like, at the moment it's almost like a meta ball. We can increase or decrease the number of points. Okay, but we don't need to have vector p field. We can simply use something like a plane, for example. So now it's just a plane, and I can resize the plane. Let's check out the points of this plane. So this is my plane, 4x4. I can resize these. So we have another shape, and we can change the amplitude. You can see how it's generating result. We can use circle donut, and this might give us like something that looks like a biscuit. Occasionally it gives an interesting shapes. Okay. I think this one is almost like a donut. So there's inverse square, so I can play around with this formula as well. So that's almost like a biscuit. There's this resample value you can adjust. And there's also this value over here. So that looks like a cracker or something. And if we increase the value, so here I'm actually I can control the bounding box. There, that looks like a cookie or something. So it generates weird random stuff based on a value. Think of it like a little bit like volumetric. So you can end up with really weird surface that's really hard to model, as they're kind of like non-manifold or it's kind of like connected with each other. It's like inside of a plant or something. So this one is very easy to see. It's 4. I can change the value here. It's like a donut, and they're kind of like merging with each other. I can increase the number. Same thing with this n-gon. If I use it as the center, again we have like a cookie. You can change the number. You can randomize. That's actually kind of interesting, similar to what I created earlier. I wonder if we can have a different radius, random number, plug this in. Yeah, apparently we can. I think that's pretty cool. Amplitude and this value, isosurface value. So this is marching cubes. It's still kind of, it's weird for me. I don't know all the formula to create this. Actually, lots of this doesn't work. But just inverse 1 divided by radius seems to be working. Average, nearest, separate doesn't work. But circle, point, line. Okay, we can have line as well with the directions. Can be pretty handy. Oh, look at this. And the vector with 5 points. Look at this. They're low. You can create like a tree this way. All the weirdness that you can create using simple marching cubes. Point line. This is almost like a, because it's a volume, right? You can have mesh, face, edges, plane. line is really interesting. So look at this. Let's say we have 20 of this and 20 of this, 20 random value. This definitely requires more ISO value, more subdivision. So increase this by twice. It's gonna be really slow. It's not too bad. Now we have this. It's really powerful actually. Maybe I should play around more with this. But this can create a character. Maybe some kind of creatures. Because every time I look at this shape, hey, if you use like mirror, bisect it, flipped it, it's like a creatures. Sort of, I mean, it's not like, not really. But it's an idea, something you can try. And remember, you can always increase the boundary in XYZ direction. Pretty weird, huh? Yeah, it's almost like inside your body, like a cell. So this is ISO. It's really powerful. So basically, you provide it with some kind of attractor field, so fields of values, and it's using the S scalar value. Look at the value. It's basically, oh, you can't see the value. Okay, maybe you can look at it with graph. You can graph it. Scalar field graph, and you can use viewer and look at the value graphically. It needs a bound as well. So there you go. That's the scalar value of this this weird looking tree. If I randomize it, you can see how it's changing. So if I put it somewhere else, there. So this is what it's creating. So we can graph this 50 by 50 by 50, 10 by 10 by 10. So this is the field. And this is the result, 3D result. So I think those two should give you an idea. So what is this all about? A volume that you can turn into a mesh. I wonder if cycles or EV also have something similar, and you end up with a volume that, or formula that you can plug in. Circle. So this is the donut. So with the donut, this looks like this, but the viewer looks a little bit like that. Well, anyhow, I'm probably just gonna stop here. There's a lot of potential here. You give it a try yourself. See what you can come up with. So marching cubes nodes in SVerchok for Blender. So thanks again for tuning in, and I'll see you next time. Thank you. Bye.